Hello everyone, welcome back to the video. So today I'll be explaining Physics IGCSE Paper 4 Code 0625 Paper 43 October November 2019. Let's get started with the first question. Question 1 states Figure 1.1 is the top view of the tank on an aquarium. The tank is filled with salt water. The depth of the water in the tank is 2 meters. Calculate the volume. So volume is equal to area of the base times height. So it will be 1 times 3.2 plus 2.2 times 1.6 multiplied by 2, which is 9.9 meters cube. So this is the volume of the water in the tank. Part B states the density of the water in the tank is 1.1 meter per times 10 to the power of 3 kilograms per meter cube. Calculate the mass of the water. So density is equal to mass divided by volume, and mass is equal to density multiplied by volume, which is 1.1 times 10 to the power of 3 times 9.9, that is 1.1 times 10 to the power of 4. So 1.1 times 10 to the power of 4 is the final answer for part B. Part C states calculate the pressure due to the water at level 0.8 meters above the base of the tank. So first we have to calculate the depth, which is 2 minus 0.8, and that is 1.2. Then pressure is equal to HPG, which is 1.2 times 1.1 times multiplied by 10 to the power of 3, 10. So that is 1.3 times 10 to the power of 4 pascals. So 1.3 times 10 to the power of 4 pascal is the final answer. Question 2, part A states state in words the equation of the that defines the movement of the force. Moment of force is equal to force times perpendicular distance from the pivot. Part 2 states state what is meant by the moment of the force. A moment of the force means the turning effect, which means the point from which the object turns, that's the moment of force. And third question states force is a vector quantity. Explain what is meant by the term vector. So the vector is a quality that has both a magnitude as well as a direction, meaning when the object moves, first it has a magnitude, which is the force, and the direction, which means the direction in which the force is being applied. Part B states explain how the counterweight prevents the crane from toppling over. The counterweight provides an anti-clockwise moment. This anti-clockwise moment is equal to the clockwise moment provided by the load. So this is how the counterweight prevents the crane from toppling over. Question 3, Part A states Figure 3.1 shows the waterfall. Part 1 states describe the main energy transfers which is taking place as the water falls. The main energy changes from gravitational potential energy into kinetic energy. Part 2 states the speed of the water as it hits the bottom is 221 meters per second. Calculate the height of the waterfall. So Ke gained is equal to potential energy loss. So Ke formula is 1 over 2 times mass times volume squared is equal to mgh. So we will rearrange and we will write h is equal to v squared divided by 2g. So when we input the from values, it will be 22 meters. So the height is 22 meters. Part 3 states state and explain any assumption you might have made in part 2. No energy is lost to the surrounding as thermal energy, because that's the main energy that is in which the energy is lost. Question B states the sun is the source of energy for most energy resources used to produce electricity. Two energy resources that have another source for the energy, which is geothermal, nuclear, and tidal. So these are more like two you have to write, and I have added the third one just for in case if you don't remember the first two. So this is the final answer for part B. Question 4 states solids have fixed shape, liquids adapt to the shape of the container, gases fill the container. Explain the terms of these forces between molecules and arrangement of the molecules. Why solids, liquids, and gases have these properties? Solids, the molecules are in a solid arrangement. There exist there exist strong forces of attraction between the molecules. For liquids, the average forces are too weak to keep the molecules in definite pattern, and in gases, the gases are far away from each other, and so there are weak forces between the molecules except during collision. So when they hit the wall of the object, they have increased their velocity, so they will have more force in them after hitting the after having a collision with the object boundaries. So this is how we'll be doing question 4. Question 5 states an electric kettle contains water at a temperature of 19 degrees Celsius. The kettle has a power rating of 3 kilowatts and is switched on for 3.5 minutes. Calculate energy supplied to the kettle by the electricity supply. So energy is equal to power times time. So this is the formula. We input the values and the energy calculated is 630,000 joules. So 630,000 joules is the final answer. Part B states at 3.5 minutes the temperature of the water reaches 100 degrees Celsius. The volume of the water in the kettle is 1700 centimeter cube and its density is 1 gram per centimeter cube. The specific heat capacity of the water is 4200 joules per kilogram degree Celsius. So we have to calculate thermal energy. So we rearrange the formula of energy, which is m is equal to this, and we calculate first the mass. Then thermal change in temperature is this, which is 81. Then we calculate energy gained by the water. So 1700 divided by 1000 multiplied by 4200 multiplied by 81, which is the, here we have already calculated here change in temperature. So 580,000 joules is the final answer for thermal energy. So 580,000 joules is the final answer. Part C states the calculate the efficiency of the kettle. So efficiency is equal to used energy output divided by total energy input. So useful energy is 580,000 and total energy input, which we have already calculated, is 630. So 580,000 divided by 630,000, which is the percentage. So percentage is 92%. So efficiency of the kettle is 92%. So this is the final answer of part C. Question 6 states, state the name given to a region around A in the diagram. So this is a compression where all molecules, all lines are or waves are close together. Then second is the region around B. In B region, it's most away from each other. So this is rarefaction. Part B states on figure 6.1, draw a double-headed arrow to show the wavelength. So the wavelength starts from here till here, which is one wave. So part C states the loudness of the sound increases at the same pitch. See to explain any change that there would be in the pattern of the wavefronts in the figure 6.1. The wavefronts are closer together at compression and further apart at rarefaction. Part D states the wave passes into water. State and explain any change in the pattern of the wavefront shown in figure 6.1. They are spread out from each other and the velocity is greater in the water than in the air. So this will be the final answer for part D. Question 7 part A states the figure 7.1 shows the position converging lens, its principal axis and an object O. So this is the figure 7.1. It states each principal focus of the lens is about labeled F. And on figure 7.1, draw a ray diagram to locate the position of the image formed by the lens. Label the image I. So according to my graph, the object is made over here, but if you do it from your end, it may be made over here, over here. It depends on how you're drawing the lines. Part B states, describe the nature of the image I. Image I is enlarged and upright and visual, meaning it's in the same direction where the object is, and it's enlarged meaning it's bigger, and upright meaning it's straight, not inverted. Part C states image formed by the lenses sometimes have colored edges. Suggest the reason for this. Because different colors have different wavelengths, meaning if you're not using white light or red light, you're using a different light, so it will have a different colored edges. So this is the final answer for question C. Question 8 part A states figure 8.1 shows a negatively charged conducting sphere. On the figure 8.1, draw the electric field pattern around the sphere. So for electric sphere, the electric sphere is, which is negatively charged, will attract energy towards it. So all the arrows will be pointing towards the sphere. Part B states the current in the electrical device is 0.21 amps. Calculate the charge that flows during a 75-second period of the time. So Q is the charge is equal to I times T, which is current times time. So 0.21 times 75 seconds, which is 16 C, which is charge 16 C. So charge is 16 C. So this will be the final answer for part B. Question 9 states figure 9.1 shows a circuit containing an LED and two resistors in a parallel, each of resistance R. The normal operating voltage of the LED is 2.1 volts and the normal current is 0.19 amps. Part A, Part 1 states the potential difference PD across the LED is measured with a voltmeter. On figure 9.1, draw the symbol of this voltmeter connected to the circuit. So this is the voltmeter connected to the circuit across the resistor, which is LED circuit. So this is how we'll be doing this. Part 2 states the current in the LED is measured with an ammeter. Draw the symbol for the ammeter connected to the circuit. So here we will be connecting the ammeter, which is A. Part B states calculate the value of R when LED is operating normally. So I current is 0.19, voltage across the resistor R is 3.7 minus 2.1, which is 1.6, and the value of R divided by 2, which is equal to V divided by I. So 1.6 divided by 0.19, 8.4. So 8.4 multiplied by 2, which will be 17. So 17 will be the final answer. 17 ohms will be the final answer for part B. Question 10, part A states a magnet and a coil are attached separately to a door and the door frame is shown in the figure 10.1. So this is a diagram which is figure 10.1. Initially the door is closed and then it is operated. Explain part 1. Explain why the indicator comes on and then goes off when the door is open. Movement of the magnet induces a current in the LED and the light goes off when the magnet is no longer below the coil. Part 2 states the door shuts, the indicator comes on and more brightly but for a shorter time than it did in part 1. So just to explain why this happens. The main reason is the door closes more quickly than it was open and so there is a higher current in the LED. The magnet is moving for a shorter period of time, so the indicator comes on more brightly but for a shorter period of time. So this is the final answer for part 2 of question 10. Part B states a circuit breaker is recommended to use with an electric lawnmower. State two reasons for this recommendation. So first reason is it protects against overheating. Second reason is quick response. Third is easily resettable. And last one is protects against electrical shock. So here we have to write only two reasons, but I have given four reasons so that if you don't remember or are not clear with any of these, you can use the other two, which is easy for you to remember. So this is how we'll be solving part B of question 10. Question 11, part A states the circle shown in figure 11.1 represent three gold nuclei. Three alpha particles are approaching a gold nuclei. So on figure 11.1, complete the path of each alpha particle. So the alpha particle will not touch or be attracted towards the gold nuclei, so it will be diverted away from it. So either the alpha particle will reflect back towards where it is coming, or it would divert itself to upper direction or even towards the downward direction. So these are the direction that the alpha particle will use to stop itself from touching the gold nuclei. Part B states a detector of radioactivity in a laboratory indicates an average of 16 counts per minute when no radioactive samples are present. A radioactive sample of half-life of 1.5 days is placed close to the detector, which indicates a count rate of 208 counts per minute. Calculate the count rate that is indicated 6 days later. So counts due to the radioactive source is 208 minus 16, which is 192. Half-life is 1.5, and half-life times 4, which is 16, and which is 16. So 4 half-lives must be completed after 6 days. So 196 divided by 16 is 12 and 12 plus 16 is 28. So the count rate is 28 counts per minute after 6 days. So this is how we'll be solving this Part B of question 11. Part C states the waste from nuclear power station include the isotopes technetium 99, tin 126, and selenium 79. These isotopes are radioactive with the half-lives of many thousands of years. Stage 3 economic and environmental consequences of producing this waste. First reason or consequence is the waste must be stored with shielding. Second consequence is the waste must be stored securely. Third consequence is the waste must be transported with shielding. And the last is it is expensive to store the waste because you have to keep them protected from outside world for many thousands of years, so it's expensive to store. So these are the final answers for the question C. And guys, if you like this video, don't forget to subscribe, like this video, and share it with your friends. And if you have any question regarding this paper or any other paper, don't hesitate to comment down in the video in the comment section, and join my Discord link, which is also provided in the link of this video, where I'll be updating and helping you out if you need any questions and answers regarding any papers regarding physics and maths and so on. See you in the next video. Bye.